Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we are beginning a new topic which is multi-class and multi-output algorithms. So we'll look at the intuition behind what is multi-class, multi-label, multi-output, both for classification and regression. And then we'll look at an example of label binarizer. And finally, we'll end the video with what is classifier chain, regressor chain, and a code snippet. And in the following video, we'll do the actual coding in Python and see how each of these could be implemented. So what is multi-class classification? Let's say we have this data table here on the left hand side. We have two features, x1 and x2, and each row is a sample. So sample number 1 would be the first row, which is this one. Sample number 2 is this, and so on. And y, which is the target, uh, has three classes in this case. The first two samples or first two rows have class 1. Second, then the third sample has class 2, and the last two rows have class 3 as label. So in this case, we have one target column, and that one target column has three different classes. In generally, what we have known in case of binary classifiers is that the classes are either 0 or 1. And so in this case, we have additional third class. So we have 1, 2, and 3 classes. So that's multi-class. And here on the right hand side, I'm just showing that one sample in this case for a one row has one target, so just one target column, and that target column just assigns one class to a particular sample, and that's it, no more than one. And however, the total number of classes in the entire target column can be more than two. So here we have 3. Now let's look at what is multi-label or multi-target classifications. So multi-target is just word that I put in the docs. It's multi-label. Here, if we look at this table on the left-hand side, we again see the same set of features, x1 and x2. However, there's a difference in the targets. Instead of just one column, we now have 3 different columns for the target. So each target column has two classes, either 1 or 0. So the sample 1 in this case can belong to more than one classes from different targets. For example, here this belongs to the class 1, which is in target y1, class 1 again in target y2, and in y3 it does not belong to class 1 from the target y3. So essentially in this multiple label case, each sample can have would have more than one target and could have more than one class. And the only thing to remember is that each of those targets is going to be binary. That is, it will have just two classes, not more than two. Now, a combination of multi-class and multi-output is also there. It's also called the multitask. So here again, we have the similar table as we saw in the previous case, where we have x1 and x2. Those are the two features. And now we have 3 targets, y1, y2, and y3. In this case, however, each target can have more than 2 classes. So y1 has class 1, 2, 3. Y2 has just 2 classes. But y3 then again has 3 different classes, 1, 2, and 3. So again, in this case, each sample has more than one targets, and thus each sample has more than one classes. The biggest difference here is each target can have more than 2 classes. In previous case, each target had just 2 classes. Here it can have more than 2 classes. Now, in case of multi-output regression, it's the same analogy. We have here the data set where we have two features x1 and x2, but then instead of just one output target y, we have three output targets y1, y2, and y3. And they are continuous. What I mean by that is they are floats 1.1, 1.2, etc. So each sample, in this case sample 1, would have more than one targets, because here in this table we have three different targets. And in Scikit-learn, the format of the target can be changed using a method called label binarizer. So here what we are trying to do is converting each of the classes in the target into ones and zeros. So here we have three different classes: car, truck, and a bike. So on the right hand side on the top, we have a dense matrix where we have converted each of those classes into ones and zeros. So let's try to arrange these alphabetically. So we have B is bike would be first, car would be the second column, and truck would be the third column. So in the first case, we just have a car, which is the second column. So we just have one here, other two are zero. Then the next two, we have truck. So the last column would have ones. The first two would be zero. And so we have ones here, zero here. And the last one is bike, which would be the first column. So we have one here and then two zeros are right here. In the CSR matrix format, which is shown here below, this can be represented in this form where in parentheses these are just the indices of the locations in the matrix above where the values are not zero. That is to say the values are 1. So row 0 column 1 there is a 1. So row 0 column 1 we have 1. Row 1 column 2 we have 1, and so row 1 column 2 we have 1, and so on. Lastly we have row 3 column 0, row 3 column 0 we have 1. So that's format. So that's how we can convert the target into ones and zeros, and either of these formats can be used as an input to this methodology of multi output classification or regression. Now, here's an interesting concept of classifier chain. Let's say you have a data set such as shown here on the left hand side, which has two features, but then it has three different classes, three different targets, and each of those targets are binary. Let's say each of those classes has classes either 1 or 0. Now, if you were to use something like a linear model such as ridge, which to which traditionally if it takes only one target value as the input for training a model, then this case where we have more than one target, you'd wonder how we could use that. So that's where the classifier chain helps us use those models. When I said this, it's important to note that some of the classifiers in Scikit-learn, many of them already have a built-in functionality where they can accept multi-classes. So in case if they do not accept, then this is a way to proceed. So let's say we are using a rich classifier in a classifier chain. So the way this would work is the very first, and let's say we are trying to create three different models, classifier models in the chain. The first model will take all the features. So we have feature x1 and x2, and it will take just one target, which is y1, and then predict an output. In the next classifier, it will take the features x1, x2, and the target y1 as a feature, and then use target y2 for target y2 as the target. And so something like shown here. So we have these three are now features, and this is a target. And then similarly, when you go to the third model, you have these four that are now the input features, and y3 is then the target. So here, if we have let's say we have a test data now that we are trying to predict what the output target is going to be. In those cases, we wouldn't have these true labels y1, y2, and y3. So what would happen in those cases is the predictions from each of those models would be used as a feature in the following model during the learning process. So the prediction from this first classifier, let's say it's ypred1, that would be used as a feature when this second classifier is training. And similar to classifier chain, and of course finally then you have the predicted y that you get from as an output from this classifier chain. And similar to classifier chain, we have a regressor chain, which again where we can use something as simple as a linear regression on a multi-output target. So here we have just two features, x1 and x2, but then we have three different targets, y1, y2, and y3. So in general, what we have used previously linear regression for is just to predict one target. And if we were to use the same linear regression to predict more than one target, then regressor chain could be useful. Now, one question that you may have is, why is the chaining process so what is the importance of this chain in classification and regression? So from the docs, what I've read is that this chaining takes into account the correlation between the targets, because we are using those targets as features in the models as we step through the chain. So that's explanation for that. And finally, here in the code snippet, we have this new library that we are using now. It's multi-output, and ensemble is what we have seen in previous videos. So here we can have a data set such as shown here, created data set where we have X-train test, and then the standard scikit-learn format. We fit the model multi-output regressor on the X-train and Y-train, and then predict on the X-test. So this is the estimator that I've used here. You have the choice to use any estimators that may work on the type of data that you're trying to find answers on. So that was it for this video. I hope in this video you got an intuition about what is multi-class, multi-output, multi-label, classification regression, as well as classification regression chain and label binarizer. In the next video, we'll look at the actual implementation of some of these models on toy data sets, and just to see how they work, what are the steps involved. Until then, please like, share, and subscribe. I hope to see you all in the next video. Thank you.